Up until now, when we've been working with zeros of polynomial functions, we've either been working with quadratics or we've been working with some zeros, but we've given you some factors. So today we're going to come up with some strategies for figuring out what possible solutions or zeros we can have for polynomial functions. So our fundamental theorem of algebra says that if f of x is a polynomial of degree n, where n is greater than 0, then f has to have at least one 0 in the complex number system. And again, this is the complex number system that we worked with that deals with a real plus an imaginary part. So if, for example, let's say that we have a quadratic. Maybe our quadratic is x minus 2 squared plus 3. So we've had problems with this one if we've asked ourselves for our intercepts, because we know that if we have moved 2 to the right and 3 up, this is a polynomial or quadratic that is has a vertex of 2, 3. And because the leading coefficient is a positive 1, it's opening up. So we will move 1 to the right, 1 to the left, and will be 1 up, because 1 squared is 1. 2 to the right, 2 to the left, and we will be 4 up. So we can find the y-intercept, but we have no x-intercepts. And the reason for that is that we have no real solutions to this quadratic equation. It is shifted up, it is never going to cross the x-axis. So we can figure out what those complex solutions are. So the linear factorization theorem says that if f of x is a polynomial of degree n, where n is greater than 0, f of x has to have n zeros. Okay, if it's a third degree polynomial, it has to have 3 zeros. If it's a fifth degree polynomial, 5 zeros. And it has to have n factors. Now, remember that not all of those will be unique. Sometimes we have a multiplicity of 2, for example. We might have a 0 that occurs twice or 3 times, and so forth. So, if f of x has zeros of 2, -1, 4i, and -4i, we can ask you to write the linear factors of f of x. So f of x has zeros of a 0 of 2, that means it has a factor of x minus 2. If it has a 0 of -1, its factor is x plus 1. A 0 of 4i means that x is going to be minus 4i for a factor, and x plus 4i is the factor for the 0 of -4i. In this case, we asked you for the linear factors of it. That means we don't have to go any further. We are finished with this particular problem. The rational zero test says that if a polynomial of the form f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 down to a sub 1 x and then plus a sub 0. In other words, it's written in decreasing powers of x with its coefficients that all may be different. Then it has integer, and it has integer coefficients. Every rational zero of this has to be of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So when we want to find the rational zeros of f of x equals x cubed minus 7x minus 6, our p is our -6, factors of -6, our q are our factors of 1. So p over q means that we have a possibility of factors of 6. Well, factors of 6 are positive or -6, positive or -3, positive or -2, and positive or -1. Factors of 1 are positive or -1, and that's it. So we can write them all out, or we can just make that little listing and be comfortable with the fact that these are all the possible infinite number of rational numbers out there. These are the only ones that will be zeros of this particular polynomial. So we can use our synthetic division that we're working on perfecting to help with that. So we check, do we have all of our powers of x? X cubed, oh, we're missing an x squared. So we're going to write 1x cubed, 0x squared, -7x is -6, and we're going to try one of these possibilities. Now, many students start with the number 1 since it's easy and it's a simpler number to work with. So we'll try that. We bring our 1 down. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 2. 1, sorry. negative 7, and a positive 1 is a negative 6, and 1 times a negative 6 is a negative 6. Negative 6 plus negative 6 gets us a negative 12. So it didn't work. So let's try negative 1 with our 1, 0, negative 7, and negative 6. So we bring our 1 down, and 1 times negative 1 is negative 1, 0 and negative 1 is negative 1. 1 times negative 1 is a positive 1, negative 7 and 1 is negative 6. Negative 1 times negative 6 is a positive 6, and negative 6 and 6 is 0. So we have a remainder of 0. That means that negative 1 was a 0, and x minus 1 is a factor. So x, apologies about that, on that. X equals negative 1 is one of our zeros. Now that we've taken our cubic and we've found one of the factors, x plus 1, we can now have a depressed equation. So this is an x squared minus an x minus a 6. It's quadratic now. And now we can say, what's going to make this equal to 0? Well, I can factor this. X times x gives me x squared. I want factors of 6 that will subtract to become a negative 1, so I need a negative 3 and a positive 2. And then I find the other two solutions. X is going to be a negative 2 and a positive 3. So here are our 3 rational zeros of this function. To find the rational zeros of this function, same process. We check to make sure we're not missing anyone. We're going to figure out what our possible zeros are. So we have options of plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those are all the factors of 10. That's our p. We want the factors of our leading coefficient, which is our q, so we can have a plus or minus 1, a plus or minus 3. So net result is we could have 1 over 1, 1 over 3, 2 over 1, 2 over 3, 5 over 1, 5 over 3, 10 over 1, 10 over 3, plus all of those negatives. So we're going to write out our synthetic division problem. We have a 3, a negative 20, a 23, and a 10. We're not missing anyone. And we're going to try 1. When we try 1, 3 comes down. We get 1 times 3, which is 3. Negative 20 and 3 is a negative 17. 1 times negative 17 is a negative 17. 23 minus 17 is 6. 1 times 6 is going to get us 6, and 10 and 6 is 16, not a 0. Let's try 2. So a lot of this is just try until you find it, making sure that you don't make mistakes, don't go too fast. We'll try 2 now because positive 1 didn't work. 3 comes down. 2 times 3 is 6, negative 20 and 6 is negative 14. 2 times negative 14 is negative 28. Negative 28 and a positive 23 is a negative 5. That looks promising. 2 times negative 5 is a negative 10. Negative 10 plus 10 is 0. So we now have one of our rational zeros. 2 is one of our zeros. Then we have a cubic that has now become a quadratic, 3x squared minus 14x minus 5. So we can multiply the 3 times the negative 5 and get negative 15 and ask ourselves what are factors of negative 15 that will subtract to become a negative 14. So that would be a negative 15 and a positive 1. So we write our 3x squared, we write our negative 15x, we write our positive 1x, and we write our minus 5, and that is going to be equal to 0, factoring by grouping. We factor a 3x out, we're left with an x minus 5. Lo and behold, here's another x minus 5 that is taken times a positive 1. So 3x plus 1 is one of our factors, and x minus 5 is the other. That means that positive 5 is one of our solutions, and if 3x plus 1 equals 0, 3x is a negative 1, and so x is a negative 1/3. We have our 3 zeros. So complex zeros have to travel together. If a plus bi is one of our solutions, then a minus bi is going to be another if we have real coefficients, because they have to multiply together to eliminate the imaginary part. So if we ask you to write a 4th degree polynomial with 0, 1, and I as its zeros, 0 is one of our factors, x minus 0, or just plain old x. 1 is one of our factors, x minus 1. And then if we want to have I as one of our factors, x minus I, as one of our zeros, so x minus I is one of our factors, then that means that negative I also has to be a 0, and so x plus I will be our other factor. This is not a polynomial, this is the factored form, so we need to multiply these out. We want to multiply these two together first before we multiply them by the others. So x times x is an x squared. Outsides, insides are going to be 0 by definition or by design. And a negative I times a positive I is a negative I squared, which is a positive 1. Then we have x times x minus 1, so we will have an x squared minus x. We want to multiply these two binomials together, and that's going to get us our 4th degree quartic polynomial. So f of x is going to be, well, x squared times x squared is x to the 4th. X squared times 1 is a positive x squared. Negative x times x squared is a negative x cubed, and negative x times a 1 is a negative x. Writing it in descending powers of x, we get x to the 4th minus x cubed plus x squared minus x. To find all of the zeros of this polynomial, when we are told that x plus 3i is one zero, means that we are going to have x minus 3i as a second zero. So when we know that these are both our zeros, we can write them in factored form. We can say x minus 2 minus 3i is one of our factors, and x minus 2 plus 3i is another factor. So let's multiply them together using product boxes for organizational purposes this time. So x times x is x squared, x times a negative 2 is a negative 2x, x times a negative 3i is a negative 3xi, negative 2 times x is a negative 2x, negative 2 times negative 2 is a positive 4, negative 2 times a negative 3i is a positive 6i. Negative 3i times x is a positive 3i times x is a positive 3xi. Positive 3i times a negative 2 is going to become a negative 6i. And negative 3i times a positive 3i is a negative 9i squared, which is the same thing as a positive 9. Now on our diagonals, we should start to see some things that will combine. So x squared is it for our first term, and we have there we go. We will have a negative 4x, and positive 3xi, negative 3xi are gone, negative 6i, positive 6i, also a zero pair, and so we have 4 plus 9, which is 13. So that is one of the factors of x to the 4th minus 4x cubed plus 12x squared plus 4x minus 13. So we know how to long divide that by x squared minus 4x plus 13, and when we finish we should have a remainder of 0. So we ask ourselves, what do we have to multiply x squared by to get x to the 4th? And the answer is x squared. So we multiply it out, x to the 4th. Negative 4 times x squared is a negative 4x cubed. 13 times x squared will be a positive 13x squared. And then it's a good idea to grab your other new color and change all of your signs. And now we're back to subtracting. X to the 4th minus x to the 4th is a zero pair, another zero pair. We'll have a negative negative 1x cubed. Negative 1x squared. Bring down our 4x and our minus 13. And when we take x squared times a negative 1, we'll get a negative x squared. Negative 4x times a negative 1 is a positive 4x, and a positive 13 times a negative 1 is a negative 13, we change all of our signs, we will get a 0. So our first factor times x squared minus 1 will help us get our other zeros. X squared minus 1 is something that factors into an x minus 1 and an x plus 1. And so if they are going to be equal to 0, we know 2 plus 3i is 1, 0, 2 minus 3i is a second, a positive 1 is a third, and a negative 1 is a fourth. There's your assignment. Bold and underlined are required. Others are encouraged for extra practice, make you confident, make you efficient when you get ready for tests and quizzes.